So we talked about the admin distance as a feature that can be used in iOS to determine between different routing protocols and give preference to certain routes from different routing sources. But of other protocol independent features, of course, what we said that we are going to talk about here, let me find that one. Where is that one slide that we used with these protocol independent features? Where are they? This is not the one, this is the one. Oh, this is the one. So let's talk about the network statement. Now, when I talk about the network statement, so let me write it down here, network statement. The first thing here is that I really like to make a distinction between what network statement does in BGP, which is not something that I'm going to talk about today, because today we are going to be talking only about the IGPs and what the network statement does in IGPs. Now, for all IGPs, what network statement does, it enables protocol on interface. I should say really on interfaces, because it could be multiple interfaces. But what do we actually mean when we say that the network statement enables the protocol on the interface? Well, there are actually three things that happen when you type out the network statement. What is going to happen? Number one is protocol related data is going to be sent on interface. Protocol related data is received on interface. And number three, network, or I should say maybe IP network, associated with the interface is advertised, or I should say injected, into the protocol database. So these are the three things that always happen when you use the network statement on the interface. But what is the protocol related data? Now, that heavily depends on which protocol you're using. In a case of RIP, those would be the RIP updates. In a case of EIGRP, those would be the EIGRP hellos and EIGRP routing updates. In case of OSPF, those would be OSPF hellos, the link state updates, the link state requests, the link state acknowledgements, and the database descriptor. So all of those things will be sent and received and processed on the interface that is actually enabled for OSPF if you use the network statement. But one thing here that remains still unanswered is on which interfaces. So let's say that on a router I had several interfaces configured. Let's say that I had interface X1 that had IP address 192.168.0.1, and same in the typing /24. And here interface X2, I had IP address 192.168.1.1/24, and I configure a router, let's say X, whatever the protocol is, and I say network 192.168.0.0. So which of these interfaces will be enabled for this protocol? Now, if we take a look at this statement here and think of it as, okay, I need to find the interface that matches this exactly, none of these interfaces will actually match because these are both /24s. Now, this is not how network statement works. what network statement does is actually it creates what I like to call the pseudo access list. So think of this statement here as if it was an access list. Now, all the interfaces that have an IP address that matches this access list here will actually be enabled for protocol X. So this statement here that comes after the network keyword is actually an access list. Now, that said, all three protocols that you care about, RIP, EIGRP, and OSPF, have a different syntax for the network statement. Now, for RIP, the syntax is network, and then you enter the net. Now, the net here is a classful network. Even though you may be running RIP version 2, which is classless in itself, the network statement itself is classful, which means that it is aware of A, B, and C network classes. That means that you need to be very, very careful when you are using RIP and when you're enabling RIP on interfaces, because when you enable interface, for example, in class B, you might be enabling more than just the interface that you want to enable. EIGRP, on the other hand, has two formats for the network statement. One is network, where you give it just a network, and in this case, it is going to be a classful network. Again, aware of classes A, B, and C. Or we can use network, followed by the wildcard mask. Now, if you use this format here, the network statement is actually classless, which means that you can match only particular interfaces or only different subnets of major networks from class A, B, and C, but it is classless. So basically, you can use the wildcard mask. Now, for those of you who are very good with access lists, I should point out that this must be contiguous. In other words, this is inverse net mask. That means that all that trickery that you can actually do with the wildcard masks that you are using for access lists, here you can't really do. So wildcard mask that is perfectly valid in an access list, for example 8.64.4.0, would be an invalid here because this needs to be an inverted net mask, which is also good news because iOS is actually intelligent enough to tell, are you typing a net mask or are you typing an inverted net mask? So if you type an inverted net mask, it will use the inverted net mask as is. But if you are typing a net mask, so for example, you type network 192.168.0.0 space 255.255.255.0, iOS will say, okay, so he actually typed out the net mask, and what ends up in the running config is actually an inverted net mask, which is good news because what you can do is you can take whatever was configured, for example, on the interface that you want to enable for EIGRP, IP address, blah, blah, you just take, copy, and paste that into the network statement, and EIGRP in iOS will actually be intelligent enough to convert this to what you need to have. So it's a very, very neat shortcut to prevent fat fingering the IP addresses when you are typing them in, or for making terrible mistakes of enabling EIGRP where you don't want to have it enabled. So worth trying it out. Now, for OSPF, the network statement has only one format, which is network, the wildcard mask, and then area, and the ID of the area. Again, the wildcard mask, just like for EIGRP, is inverted net mask. And the same shortcut that I mentioned for EIGRP, you can actually use for OSPF, and it will work the same way. So this is good stuff. Now, when I talk about network statement, and I mentioned about RIP, that the network statement is classful. Now, there is one more thing about the RIP network statement that I want to warn you about. So let me go to my R2, R4, R5 here. And on R4, I'm just briefly going to configure relatively simple configuration of RIP. So what I want is version 2, no auto summary. I want to set an offset list for all the routes to offset route coming in by 10 hops, routes going out by 4 hops. I also want to change timers basic. So I want to speed this up. So I want to set the update to be 1 second, and invalid I want to be 30 seconds, hold down 30 seconds, flush 30 seconds. Let me see, there is one more thing that I want to do. Yes, I want to have passive interface default. I want no validate update source. So let me see this config. Where did it go? So everything that I just typed out, this relatively simple configuration in RIP, is now gone from the iOS, as if I didn't actually type it out. Now, don't be scared, the configuration is still there, iOS is just not showing it to you. When you configure RIP, if you don't configure at least one network statement, everything that you typed when you exit the RIP configuration process is going to be removed from the running config. iOS still maintains a trace of it. So even if I save the configuration here, if I do show run, you see, I don't see it, so it's not being saved because it's not part of the running config. But if I go into the router RIP and I say network, for example, 10.0.0.0, if I do show run section router RIP, it will be back there. So iOS somewhere in its memory keeps track of what you have typed. So you don't have to retype it all over again unless you reboot the router. But unless you use the network statement, it's actually going to discard it from the running configuration because it thinks, okay, if he didn't configure the network statement, what's the point of actually having RIP configured? So be on a lookout for this. And there is a long-standing myth, and I'm going to emphasize this myth, it is not true, that in the CCI lab, during the CCI lab, the lab proctors are actually going to log into your devices and mess with your configurations. Again, this is not true, but this is one of the sources of this myth, because students would configure RIP, they would configure everything that needs to be configured in RIP except for the network statement. They would log out from the RIP, or not log out, but exit the RIP configuration process. They would go and do something else, and then would scratch their heads, hey, hold on, why is my RIP not working? They would go back and see that the RIP configuration was gone. And who is it to blame? Of course, it was the evil proctor in the corner of the room messing with their config. Again, not true. It was iOS messing with them. So in a way, maybe it was a proctor, but only in a way that he was a Cisco employee and it's a Cisco iOS that does this to you. But be on the lookout for this, because this can really, really trip you off in the lab if you don't remember this feature. But remember this, then you don't have to retype everything you typed out. It's there somewhere in iOS memory, not in the running configuration. But once you type out the network statement, all the advanced configurations that you actually configured is going to be back in the running config. So that's the warning that I wanted to give you about the network statement in RIP. Another thing that I want to talk about here when it comes to protocol independent features is the feature that is relatively often used, which is called passive interface. Now, there is, again, just like with many things that I talked about today, there is somewhat of a misconception what passive interface does. So let's go back to one of the previous examples here, where I talked about what happens when you actually use a network statement on a particular interface. So let's paste this in here. So this is what happens on an interface when you use the network statement. Now, when you declare a particular interface as passive, what is going to happen on that interface, regardless of the protocol in use, this thing here, thing number 1, is not going to happen. So this functionality is disabled. But these two functionalities, that protocol-related data is received and that the network is advertised as the internal, still happens. This is true for all IGP routing protocols. This is true for RIP. This is true for EIGRP. This is true for OSPF. Now, you may be shaking your heads right now, at least some of you, thinking that, hey, wait, but that's not exactly what happens. When I declare interface as passive for EIGRP, it's very different than when I declare it passive for RIP. Well, the end result may be different, but what happens is always the same. Now, think about it. When you declare an interface as passive for RIP, you are going to prevent this router from sending the routing updates out of this interface. Why? Because routing updates are the protocol related data in case of RIP. If you receive routing updates on that interface, you are still going to accept and process them. Why? Because this interface is enabled for RIP. Now, for EIGRP and OSPF, you cannot exchange the routes between the neighbors before you form an adjacency. And you cannot form an adjacency before the neighbors know about each other. So when you declare interface as passive, you are preventing the router from sending hellos. If you are not sending hellos, you cannot form the neighborship with the router next to you, so you cannot possibly send or receive routing updates. This is why I say the behavior is the same, it's the net result that is somewhat different. For EIGRP and OSPF, you will not form adjacencies, therefore you will not be sending any routing updates or receiving any routing updates. But for RIP, you are only not going to be sending routing updates, but if you receive routing updates, they will still be accepted. Let me show you that. So I'm going to go back to my R2, R5, and R4, and I'm going to remove all the routing processes on my my three routers. So let me do that. So I'm going to say no router OSPF 25, 250, 45, 450. I forgot which ones I used, to be honest. So I'm just going to remove anything that I can think of. I'm going to say no router RIP. I believe that I have that one somewhere. So I'm going to go here to R2, remove that, remove that, remove that. So let's see if I actually have anything running. No. Show IP protocol, nothing. And show IP protocol here. Nothing. So I don't have anything running right now. And let me quickly configure router RIP. So router RIP, no auto summary, version 2, and let's run RIP on all the interfaces. So this is going to be configuration on R2, configuration on R5, and configuration on R4. Now on R5, if I do show IP route RIP, in this case, take a look, I'm receiving this route 24000/24 from two of my neighbors. I'm receiving it from R2 and I'm receiving it from R4. Remember, that was the loopback 24 that we added to test that admin distance behavior. So let me add now on R5. I actually believe that I already have it. I do have loopback. Yep, there it is. So let's focus just on the loopback of R5. So R5 is now advertising the loopback to R2, and if I go to R4, I have show IP route RIP, and I have the same thing here. So now I'm going to make one little change on router R5. I'm going to remove the process completely, right here, and I'm going to declare the interface to R2 as passive before I type in the network statement. So I'm putting back the routing process in place. So if I do show IP route RIP, nothing is going to be showing up yet, so we might need to wait 30 seconds. So take a look at this. On R5, right now, I again have two routes. So even though passive interface was active on serial 020, the routing update was accepted and processed, but R2 is having no routes received from R5. Again, I'm not sending any protocol related data, but I am receiving and actually processing it. On R4, on the other hand, if I do show IP route RIP, I still have R5's route, right, because that interface wasn't passive. And on R5, I actually have two routes, one received from R4 and the other one received from R2. So this here is the behavior of the passive interface when used in combination with the RIP process. For EIGRP and OSPF, passive interface is very, very straightforward, but for RIP, you always need to be on a lookout. RIP will always be the problem in the lab. And again, 2013, what is RIP even doing on the lab? Well, this is what it's doing. It's making the lab more difficult than it's supposed to be. So when you have two routers, and let's say that this is R1, this is R2, and you are running RIP between them, and for whatever reason you do not want to receive the RIP updates from this router R2, declaring this interface here as passive is not the solution. What you need to do is something more. If you want to prevent these routes from coming in, you may need to use distribute lists. You may need to use the offset list. You may need to use the admin distance tweaks. You may need to use RIP authentication. You can even use QoS to block update. You can use control plane policing. If you have access to, for example, switch that is sitting here in between the two. Oops, wrong button. You may want to use VLAN access lists on switch, etc. So if you want to block these updates from coming in, you may need to resort to one of these here things. And this is just scratching the surface of what can be done to prevent the routing update from R2 to coming in to R1. But this is where I always like to twist the tables. What if this was a troubleshooting question that said, why is R1 not receiving RIP updates from R2? Here are just some of the reasons why this would be the case. So you see, 1, 2, 3, 4, 5, 6, 7 in about 30 seconds that I came up with. Can you imagine how many reasons or how many different problems Cisco can come up with in all their time and knowledge in the world to actually put in the exam? Very, very simple ticket. I mean, when you look at it, when you see this in the exam, for example, troubleshooting ticket number 3, R1 is not receiving RIP updates from R2. What could possibly be wrong? How hard can this be? Well, that hard. One of the questions that I received about RIP is to explore the default route origination in RIP a little bit. So what I'm going to do now is, again, we are still on the same network as before, which is R2, R5, and R4. Now, what I'm going to do next is I am actually going to remove this passive interface so that we just have normal RIP running between these two routers. So I'm going to have R2, R5, and R4. So R2, R5, and R4. And I'm going to remove the passive interface from R5 so that I can actually see the default route in action. So what I'm going to do here is I'm going to say no passive interface this, which means that on R2 I should be getting at some point the RIP routes, and of course every time I want to do something it takes forever. There we go. So now we are getting the route. So we now know that the routes are propagating between these three routers. So I'm going to go to R4 now, and in the router RIP process I'm going to say default information originate. So let's see here if this is actually going to inject the default route. So if I do show IP route rip, here on R5, I'm not yet receiving anything. If I take a look on R4, show IP rip database, it says here that I do have the auto summary for 0000, and it says that I am redistributing this route. So maybe it's just a matter of waiting a little bit, but there we go. Oh no, hold on a second. I did have a static route. That was the old configuration there that is now tripping me up. So let me remove it. So show IP rip database. Okay. Maybe we just need to wait. There it is. Now it arrived. So if I do show IP route rip, I will see that R5 actually received the default route from R4. So typing just default information originate in RIP will actually unconditionally inject the default route. So we are going to inject the route even if we have it or if we don't. So show IP route. Here we don't have the default route. It was never configured. So if I do show IP RIP database, I can see it's auto summary, it's created, it is being redistributed, and it says it's learned via 0000, which basically tells me it is my local route. And this, we will see, is now visible on R5. And if I go to R2, show IP route RIP, I'm going to see this route in the routing table. So this is one way of injecting the default route in RIP. Now, another way of injecting the default route in RIP is, of course, to redistribute it from another source. So what I'm going to do now on R2 is I'm going to create a default route that is going to point to null 0. So if I do show IP route RIP, I will see now that I no longer have the default RIP route, but if I do show IP route, I will see now that I do have a static route pointing to null 0. That is the default route. So if I go to router RIP, I can say redistribute static, let's say metric, well, let's not say any metric, but let's say just redistribute static. If I go to R5, if I do show IP route RIP, now I will see that I actually have two RIP routes. One that was learned from R4 that was injected with default information originate, and another one that was simply redistributed into RIP. So when it comes to the default route behavior in RIP, there is really nothing special that you have to be worried about. You don't have to already have it in order to inject it, like you need for example, OSPF, or that you might need for BGP, but for RIP, it will simply generate the default route and advertise it in the RIP as if it was redistributed from another source. Also, unlike, for example, OSPF, where you need to specially tell OSPF that you actually do want to redistribute the external default route. For RIP, this is not something that you have to do even when you are redistributing from another protocol. And I use the static route as an example, but any protocol will have the exact same behavior. So if you had an OSPF default route in the routing table and you redistributed from OSPF into RIP, you would have received that default route anyways. So default routes are something that you may or may not encounter in the CCI lab. Generally speaking, you are not allowed to use default routes, just like with static routes. But sometimes, to test you on these unusual behaviors usually associated with the default routes, in the exam they might throw in a default route to kind of see if you understand what is the behavior. Because let's face it, unless you are running an ISP of about, I would say, medium size, you do have a default route somewhere in your network. Only in the ISP backbone network you have absence of default routes. So they want to have the full BGP routing tables and they are following the traffic. If they don't have the route to a specific destination, they're simply going to be dropping the traffic because it's a bogus traffic. So unless you are an ISP, you are dealing with the default route somewhere. And the CCI routing and switching exam is about the enterprise networks, and in most enterprise networks we actually do have to deal with default routes, at least somewhere in the network. So it stands to reason that they would actually test you to see the behavior of default routes. But generally speaking, you can't just go in there and add the default route. You have to be explicitly asked to do that. Just like for the static routes, they are relatively big no-no in the CCI lab.